Welcome to episode 2, everybody. Hope you guys were able to catch episode 1. If not, I'm sure we'll have these video archived for you to download later on. But what we're doing in these series is covering 3 topics, basically outlining the productivity updates that you get as part of updating to the latest version of MillBox. And if you're not on MillBox, we're kind of showing you some of the tools that you're missing out on. So if you're either a Sun 3D user or you are using a different CAM software, this can kind of give you a good idea of some of the key features that we'd like to highlight in the CAM. So let's go ahead and get started on that, and we'll talk about those 3 features that we're going to talk about today. So the first feature we're going to go over is the queued import of restorations. And why is this important? Well, when we're importing jobs into MillBox, MillBox is effectively scanning these files, and it's checking the surface features of these files to see if it has margins that it needs to auto detect, to see if your abutment or screw retain restoration has a screw hole or an axis that it needs to respect. So all of that information is gone over and determined during the initial import stage, and being able to bulk import more than one STL is a huge time-saving factor, and we'll kind of go over that as well. And so talking about the overstructure object type, so this was an object type that we introduced, I believe, back in 2018. We've since improved our detection for those objects. We'll talk about some of the requirements for those, and we'll talk about just general overall improvement on the CAM's ability to recognize surfaces and parts. And then we're also going to talk about the cavity fit values and how those values are customizable. So how you can affect fit on your restorations without necessarily needing to redesign the file or re-CAD the file, or maybe you're using a new material and that material doesn't quite mill the same, and so maybe you're getting a little bit tight fit on those restorations, and we can talk about how you can use the cavity fit operation to improve those scenarios. So now that we've talked about that, let's go ahead and go straight into the software, and then we can start talking about these features. So first up is the queued import of our restorations. So we're going to start by, I'm just going to open up a job for a 52D machine, and we'll use the C clamp. It doesn't really matter for this. And at this stage is where I can go ahead and import files. So typically your files are going to be either sorted by subdirectory if you're using ExoCAD. If you're using 3Shape, 3Shape just kind of dumps all your parts into one folder just like this. Now, there's a couple different things you can do to make it easier to process these cases, but we want to think about how long it takes to import a particular file. So let me import this 4-unit bridge. And just as an example, we'll see how long it takes to import versus an anatomical or anterior crown. So we'll pull in both of those at the same time, and you can see here in my upper left-hand corner that the bridge is loading, and so is that anterior crown. But actually, the crown just finished loading. So and I imported it as a full contour bridge. So the CAM was intelligent enough to recognize that and to let us know, hey, you imported this as a bridge, but we only found one margin line. So it wants us to double check that we made the correct selection during import, which is always very important. So I'm actually glad that happened. But you can see that the bridge, because there's a little bit more information in this bridge, there's also some undercuts there's also some undercuts in the case itself. Let's get it away from the fixture. That's why it's lighting up here. There we go. And so we can see there's plenty of undercuts here, but there are 2 margins down here. And we can see that even though it was imported as a full contour bridge, this should be switched over to a full contour restoration. So I'm going to want to get rid of that and re-import that if I needed to actually run that case. Now in this particular example, I was just doing it to show you how quickly a single unit imports versus a bridge. But the reason I wanted to illustrate that is because if you have complex cases and you're importing those, or let's say that that you're importing a couple of bridges and a couple single units, you're going to want to utilize that multi-import feature, which allows us to queue up the import of a file and continue importing that file while we queue up other files. So for example, these are all bridges. I know that this 2-unit, 4-unit, 4-unit, 6-unit, and 3 units here. So I can import these all as a full contour bridge in one step, simply hitting that plus symbol. Now the plus symbol allows me to stay at this stage and continue importing additional restorations. So if I wanted to pull in the rest of these single units, I certainly could do that and highlight those. Now I'm doing control and click. So if you do control and click, you can individually select or deselect certain files. If you do shift on your keyboard and click, then it will highlight all the files between your first selected and your second selected file in that list. But you can see that it's importing the bridge, excuse me, those bridges, but it's also importing all of my full contour crowns or restorations at the same time. And this is where MillBox and the improvements that we've made over time really scale, because you can see it's using all of my computer's resources to pull in all of those files, which is really great. Also, some of what we did improvement-wise to this feature even was we made it to where you could queue up. I think we process now up to 13 files or something like that at the same time. So it just kind of depends on your computer's performance and your rig and whether or not your processor can handle it. But as you can see, my computer's kind of stroking out here at a couple of them. So it really depends on the spec of the processor, I would say, and what affects that. But you can see the importance behind needing to be able to queue those up, so that way they can import really at the same time and pull those files all in sequence. So it's actually done importing most of these. I think we've got a couple more loading on the back end here, some of these cutback bridges and stuff, but that should finish up here very shortly, and then we'll move on. So the difference here is if I don't have, so if I'm not current on annual maintenance, then I don't have access to this feature. Now this particular feature, which is the queued import of restorations, this is technically a MillBox standard feature. So if you purchased your license anytime after August of 2019, this feature, as long as your annual maintenance is current, will automatically be there. Now, if you purchased prior to August of 2019, chances are, even if you have MillBox, you may not have this particular feature, which is the queued import of restorations. And if you don't have the queued import of restorations, the way that behavior works is as you're pulling in files, you can't simply queue them up. They're just going to process one at a time. And so when we did some math on this, and if you're doing, let's say 200 units a week on average, this is going to save you roughly about 30 minutes of processing time a week. So that's a pretty good time savings. And overall, it's about an 80% improvement in time, import time, when we're saying we're bringing in 17 units versus bringing those in one at a time. So you can see the time savings really start to add up. And I think at the end of the year, the time savings would kind of account to about 24 hours of chair time for you as a technician. So if you're the CAM technician, you're processing these day in, day out, you're constantly kind of waiting on the computer, then this is a really good way to leverage that, especially if your computer has if it's more of a high performance, because the performance scales according to your PC's specifications. And so in my particular case, I'm just running an 8-core processor, but they have certainly higher core processors out there that can leverage those speeds just a little bit more better. So next up, I'm going to pull in some overstructures. So I already have some preloaded here, just so that way we don't have to wait for that calculation time and things like, or excuse me, for the detection and all of that. But I did want to show you guys what the overstructures look like, and particularly what features we need to see on these overstructures before we can actually send these to the machine and or process them. So we have two different kinds of overstructures. So we have one overstructure type here, which does not have any screw axis channels. And then we have another type of overstructure here that does have the axis channels. So there's the import behavior is not always 100% automatic here. So it just really depends on what you have from the CAD software. So if you're using ExoCAD, for example, as your CAD software, you're going to want to make sure, along with your STL file, that you include your construction info file. If it is 3-shape, then 3Shape outputs a PTS file or a points file that goes along with the STL, and it simply gives us this margin line information that allows the CAM software to import and place that margin there for us. So in this particular example, on this particular overstructure, I've noticed that there's some additional information that was detected. It looks like there's some drilling axes that might have been detected here. And I'm not sure if this originated specifically from the construction info. I'll have to double check that just to see, or if it just detected that and thought that these were holes for any reason. Either way, we want to fix that because we don't want the CAM drilling anything there, especially when there's nothing to be drilled. So easiest way to do that is to go to our tools over here on the left menu, and then we're going to click on curves and surface tools. And then we're going to actually go in and delete the curves or caps and surfaces. So if I click this once, it just leaves the rendering as is, and I can go and click on what I need to click on. If I click that button a second time, it actually turns off the rendering of the mesh and then allows me to see the curves and surfaces. If I click it a third time, then it will show me curves, surfaces, and finishing axes determined here. So in this particular case, again, I want to get rid of these green axes because there's no actual drilling axis axes on this particular part. And once we've done that, we can see that as far as the overstructure is concerned, we have everything designated that we need to on this particular bridge, and that's mainly the margin. So when there's no drilling axis, or drilling holes, we don't have to worry about these green axes being present. Now on the other side, on this other bridge here, I've imported this case, and then I actually deleted out the margin curves that were defined, just to show you what we would have to do if we manually needed to designate this particular case. So if you ever do need to manually designate a margin on an overstructure, and that's required, because if you don't designate a margin, let's say that I was to just simply process this case as is, the danger that I run into is if there's a specific insertion direction or path of draw for this overstructure, the CAM software is not going to capture that or attempt to machine it out from that direction. And that's the reason why these curves have to be present, because that's what we essentially use to make that determination of insertion. So when I click on this bridge over here, you can click on that actual axis right here, and you can see it'll actually align it according to the path of draw for this particular overstructure. So if I even needed to make changes, I certainly could, but ideally you want to have that information straight from the CAD, so that way you don't have to make any changes there. Now, I'm going to show you manually how we would go in and designate this particular curve if it's not present. Again, this should be a minority of the cases. Now, if you're a milling center and you have no control over how these files are sent to you, this could certainly be useful to you. But if you do control your own files, you control how the CAD is outputting your files, then generally speaking, you should have a rule in place as far as your internal production. If it's 3Shape, you need to have that PTS file that goes along with the STL. If it is exocad, you need to always make sure to have that construction info file to go along with this. So what I'm doing now is kind of doing almost a little bit like connect the dots here. Basically, I'm moving my view along to kind of progress this curve. Now, again, if you have the metadata from the CAD, you'll never have to worry about this. So if you're balking at how cumbersome this is, it's not really that big of a deal in real production. This is only if you don't have those files. And even if you are a milling center, generally speaking, you're going to want to request those files from your customers. So, if it's not something you're doing today, I would go ahead and try to get into that habit of requesting the metadata from exocad or 3Shape or whatever they're designing on. And it's just going to save you a whole lot of headaches down the road. Because as far as the CAM software goes in our detection, the detection on crown and bridge works pretty well on overstructures. There is no auto detection unless you turn it on in the settings. And because these cases are so unique and oftentimes will have additional finish lines designed into the case itself, the CAM software may not be able to get a really good fix on the automated detection of that. So that's why we would want to come in here and manually kind of designate these out. So now at this point, we're almost done kind of going around here on the part. And it's worth noting that the time you spend designating this will directly impact the quality and accuracy of how this actually mills out on the machine. So you do definitely want to take your time. You don't want to go doing stuff like this, like trying to move the process along and skipping over these large swaths of where the material is, particularly because that's going to affect how we determine the insertion, right? So we want it to be as close to the actual, we'll say margin or base of this overstructure as possible. All right, and finish up here. There we go. And so we can specify if there is a thickness that you've designated in the CAD, you can put that there. Otherwise, the standard and or default value will certainly suffice. So we'll give that just a moment here now to detect an insertion direction and then plot out the margin curve here for me. So on the larger cases, of course, there's a lot of potential undercuts. So the detection of this surface may take a little bit longer than if I were going to do like a crown or bridge. Like if I was doing a crown or bridge, usually 5 seconds and then this is done. So here you can see now I've designated my margin line for this overstructure, and now we can see the insertion direction has been properly captured by the CAM software. Now, because this particular overstructure also has screw holes, we want to observe, I tell people to observe the same kind of behavior as hybrid abutments. So with hybrid abutments, you kind of have those 3 criteria for processing cases. Oh, looks like we actually have another 2 drilling axes that are not actually there that we're going to want to fix as well. And so again, I'm glad this is happening so I can show you guys the import automation works really well, say 90% of the time, but sometimes we can have these issues where it's detected additional axes and or additional surfaces we need to get rid of. So going back into our curves and surfaces tool, we can delete curves and or caps and surfaces. And you can see here, when I clicked it a second time, it showed me only curves. This time it shows me curves with surfaces. So I want to get rid of these surfaces here and those curves. There we go. Oh, looks like, okay, yep, that's perfect. There we go. Now we have a cleaner restoration. So going back to our general rules, like we were talking about on hybrid abutments, what were those rules? Well, the first rule was make sure there's a drilling axis that goes all the way down through the screw channel. And then second rule was make sure that the red caps are in place at the top and the bottom of the screw channel. So again, we see the red cap top and bottom, and that drilling axis goes from top all the way down. Same thing as we go across and look at all of these other holes. And so we can look at the bottom side as well. Now, if there's a little bit of material here that doesn't get closed off, again, that's quite all right. That's not going to cause a problem. Mainly, the purpose of these red caps is just to stop the finishing and the roughing tool paths from getting inside the screw channel, because we have our own screw channel or we have our own operation or drilling operation that will come in and automatically drill out that segment. So again, not too concerned about how that's going to turn out. Now, one other thing to also consider, this is something my colleague reminded me of. Oh, and it looks like on this other bridge, there were some other red caps or red surfaces that were detected. So we definitely don't want those to mill out. So I'm going to go in and get rid of those as well. Since this one doesn't have any holes, we don't want it capping off any surfaces, because it will actually cap those off, and if they're on an external surface where the finishing would normally occur, it'll finish those into the surface, which is not good. Okay, so we talked about those 3 criteria. Basically, you've got your drilling axis, you've got the closed hole at the top and the bottom, and then you have the margin line that's necessary at the bottom of this overstructure in order for this to mill out. Now, one other thing to keep in mind as well is in some cases you don't actually have round screw holes or round screw channels. This is mostly going to happen on angulated screw channels. So when you have an angled abutment, But it can also occur on here as well, because if you look, this is a cylinder, but you can see the shape of the actual hole is not actually a cylinder. It's actually kind of oblong here. So when you have surfaces like that, it is required for us to have the construction info file, so that way the CAM can determine the actual shape of the screw channel, and we'll use that information to drill out that hole and finish it out and make sure it's properly finished and not simply just a cylinder. So that is one thing you do want to keep in mind and is required to be able to process overstructures in the later versions, at least to do them properly. So we're going to do the stock selection. I'm just going to select a, let's say in this particular case, a 30mm disc, but it's going to be subjective based off of the cases that you're working on, of course. And then those cases would simply get nested, and then we would send these off to the mill once they're ready to go. Now, if I had additional things that I wanted to designate on these particular parts, then I certainly could specify those, but as of right now, I don't think that we have any additional surfaces that need designation. In fact, I can see there's some undercuts here along the facial. Maybe what I would do in this particular case is when I go to calculate it, just make sure that I've selected to mill all external undercuts on these parts. And in some cases where I may need to designate additional ones, you guys that had attended our episode 1 saw that we were using the milling zone designation tool to kind of show how we could hit some of those areas. So just just to recap that, I know this is not what this particular subject or topic is on, but just to show what we can do, we can come in and designate additional external finishing features here if they need to be milled out. And as you can see, it opened up that offset. So if you want to see a little bit more information about that, definitely check back on the recap for episode 1, and that'll bring you guys up to speed on how to use that additional milling zone designation tool. But as far as processing the overstructures on this particular workflow, that's about all that we need to do here. So if you guys have any questions, be sure to let us know. I think some of the other things that I would consider on overstructures are, in particular, these external undercuts. You want to make sure that those are all hit. The internal undercuts, 9 times out of 10, you're going to want to use your construction info or PTS. You're not going to want to always rely on the CAM to come in here and detect it, because if you're manually designating these, 1, it's time consuming, but 2, you introduce a margin for error. If we have that metadata straight from the CAD software, then there's no guessing. You're not leaving it up to an algorithm to determine whether or not it's the correct insertion direction. And 9 times out of 10, it will work really well, above and beyond in terms of MillBox and its ability to detect these surfaces. But at the end of the day, what you're really looking for is stable production. And what I advise people is always use that additional metadata file anytime you have that potential or capability. So next item we're going to pull up and talk about our cavity fit values. So what are those cavity fit values? When are they relevant? And how do I access those, or can I customize those? So let's pull in, I'll pull in a 2-unit bridge here, and then we'll also pull in a single crown. We'll do 2 single crowns. And then once those are imported, we'll have a look at how we can adjust cavity fit. So where could this really come in use, or where could it come in handy? Let's say that you're working with a new material, maybe it's a new PMMA that you're not quite used to cutting, and this PMMA has a lower melting point. So maybe it's gumming up on the tools a little bit. Maybe you're having some slight difficulty in success milling it out, or achieving fit from your restorations that have been milled out. Well, there's a couple different issues that I've posed there. In particular, if you see material start to gum up on your tools, that's an indication that you're not using the right settings to cut that material. Either that, or your tool is extremely worn out and it's causing friction, causing that material to heat up unnecessarily. Usually, if you have problems with your material settings, you're going to know right away. This is not something that, like, hey, I've been milling PMMA for years now, and then all of a sudden I have this issue with the PMMA and I haven't changed anything. Usually when we run into those issues that come across the help desk, customers are telling us, oh, well, we've been milling PMMA for years and we've never had this issue. But really, when we dig down into it, we find out, oh, we're using a new, let's say, harvest PMMA or something like that. That PMMA sometimes has a lower melting temperature versus others that are out mainstream on the market. And as a result of that, you actually have to use slightly different cutting parameters. So in those situations, you always want to talk to your dealer, work with your dealer to figure out, hey, what's the best material for me to use? Or there may be a material available that you didn't know about. So just to show as an example, we'll come back to this case. But when I'm selecting my materials from my material list here, you can see I have quite a few different options. There is standard PMMA, but if I scroll down, you can see there's acetyl and VisiClear, which are technically kind of in the same family, but they are different materials and they do cut different. And so, updating may improve that for you or may add those additional material profiles. And that's a good reason to stay up to date, because as we do get those new those materials hit the market, whether it's customers reporting issues to us or dealers reporting issues to us, that's generally what we try to root down to is the material different? And if it's different, then we may need to create a custom profile for it. So, all right, let's get back to talking about our custom fit. Well, because of those different cutting parameters, sometimes it may not gum up on the tools, but you may just notice that parts are not fitting quite as well as they used to, or maybe they're really tight on their fit. So generally speaking, you can have deflection, which can occur if you're using the incorrect cutting parameters or the wrong tool to cut a specific material. And that essentially leaves behind a thin film of material on here because maybe it wasn't able to cleanly cut that material away, but maybe it was able to in a way, melt it away. And so it leaves behind a little residual material. And this is where you can select any part and do this. We're gonna go to cavity fit. And we can leave a positive value, which means that we're leaving behind additional material. So we're reducing our cement space by selecting any of these values above. Any of the negative values means we're going to be cutting into the surface of the STL and we're giving ourselves additional space. So if it was a loose fit, I would come in and add additional material. In this case, I've added 100 microns to this restoration. If it was a very tight fit, I might come in and remove additional material. And in this case, this is going to be an additional 20 microns that I've removed. And one thing that you'll notice is it's all color coded. So if I go into changes here, you can very easily see the legend. This is a 20 micron reduction, and this is actually this is a 10 micron improvement. So let's go ahead and do a 50 micron reduction on the bridge. And we can say I can apply it only to the selected cavity, or I can apply it to all cavities of the selected object, or I could apply it to all cavities of all objects. So let's just do an example and I'll show you how that works. And so if I apply it to all, it just applies it to everything that's in the case. So if I'm doing something and I know it's the material and it's not necessarily the parameters that I use for that one restoration, then maybe you want to apply it to all. So what can I customize that? That was kind of the next step. Yes, you can customize that. So as long as you have access to get into your settings here, your dealer can also access your settings and assist you with this. Let's see here. Let me scroll down to where that is. Okay, it's not shown on my interface. Let me just unlock that real quick. All right. There we go. All right, and let's see here. All right, so we have thickness analysis tools here. Oh, sorry, it was right in front of my face. For some reason, I keep looking past that icon. Cavity fit, thank you. I'm sure some of the audience members like, it's right there. Okay, perfect. So now what we can do is we can actually make customizations based off of my material choice. So if it's PMMA that I'm looking to affect, I can actually say, okay, for my full contour crowns on PMMA, I want to apply a standard fit value. Now you can set that as a default. So every time I import a full contour crown in PMMA, it's always going to do this reduction. My attitude is these should be more temporary changes. And this is going to, this can vary from one production center to the next. But generally speaking, if you have problems with fit, you want to diagnose and find out what the root cause is. This is really allowing us to make adjustments on the fly and kind of go from there. And if I wanted to change some of these default values, I can actually come in and make adjustments to these default values, and it will just remember that value from that point. So if I wanted this to actually be 25 microns as opposed to 0.2, I can do that. But of course, here now I have a duplicate, so maybe I want to think about changing that along the lines further down along the line, so that way we do have unique values and unique colors. So that's how we can change the cavity fit values available here. And of course, that's how it affects us, our fit on the machine as well. So that covers the 3 topics that we wanted to go over today. And really want to thank everybody for attending today. Do we have any questions that have come in that we can answer?
Yes, Mike. Yes, we actually do. We have a few questions. The first would be, what would happen if I'm 2 upgrades behind? Do I pay twice?
That's a good question. So under normal circumstance, it would be, every year of annual maintenance is required. A few years, so like if you're 2 years behind, that would be 2 years of annual maintenance to get caught up. A couple years ago, I think we put a cap on that being the maximum you'll ever pay is 3 years. So even if you're like 6 years behind, 3 years is the max you'll pay in annual maintenance to get to the latest and greatest. Now, right now, there is a promo going on here in the US where you can, you can theoretically upgrade your software and maybe only pay 1 year of annual maintenance. Now, this depends on the license that you're currently running, and this is a very time-sensitive, time-limited factor. So I would definitely contact your dealer right now, because those promos kind of end at the end of October, and so you may not see those promos come back again. So right now is the best time to upgrade, whether you're a customer that has MillBox and you're just on an old version, or whether you're a customer that has even some 3D and you've been waiting to upgrade to MillBox for whatever reason. There's never been a better time than to upgrade today. So certainly that's a good question, and I'd say call your rep and talk to them. In the short term, that answer may be a lot less than you think.
Okay, great. The next one is support affected with the old version versus the new version?
Great question as well. Yes, so officially, we don't support we being SimSystem, the software developers, we don't support any maintenance beyond the current year. So now that we're in 2021, we technically don't support the 2020 versions. Now, does that mean that if you have an issue and it's a bug with the software, does that mean we'll leave you high and dry? Absolutely not. If there's a bug with the software, in particular, if it's an issue that, let's say, Microsoft updates Windows and that causes all MillBox customers to break, that's obviously something that we're going to fix. Now, priority is going to be for the customers that are under maintenance. So the current years being the 2021 customers, and here in a couple months, that'll be 2022. If you're on a 2020 build and we're still in the development cycle for 2020, meaning that we haven't put that kit away and can't update it for whatever reason, then certainly we have been known to go back and update those previous versions. But in terms of support, so like if you were calling us to add tools or change tool slots and things like that, that is not covered anymore when you're outside of maintenance. So whether that is support with your dealer or support with SimSystem, either direct or having been escalated, that's kind of a requirement that we have in order to be able to spend time and diagnose these types of issues that can come up with production. So it's always a safe bet to stay on the latest version, because it not only does it protect you from issues that could potentially arise, but it also gives you access to these awesome features that we're talking about in these series. So great question, thank you.
The next is, how do we get access to these upgrades?
So getting access to these upgrades, we kind of talked a little bit about it, annual maintenance. So being current on annual maintenance is like the first step. Now, the only feature that I talked about today that is in the comfort features or is part of MillBox standard is the queued import of restorations. I think we did a report, and the last report that we did, at least for Zahn customers, was something like 50% of the users out there do not have access to this queued import of restorations. And that's really important to me, because if we're talking about your productivity, this is going to make a huge difference. So even if you are a MillBox user, and even if you're behind and you don't want to pay the update fees to upgrade to the latest version, make sure you get the standard version of MillBox, so that way at a minimum you'll have the queued import of restorations, which will reduce your import time by about 80% on average. So